Hi Audrey, it's Martin. This is my 5 minute recording just showing you where I'm up to so far on the staircase project. Going through, as you see, I've started to build up the graphics for the portfolio. I'm putting a context page in here just so the staircase is in context with the interior. I thought it was quite important. Research-wise, I've looked at the eco-friendly elements. I've looked at materials. I'm going for sort of aerospace type materials, lightweight and strong. As discussed, I've looked at the process. So we're looking at the large 3D printer. So I'm looking at designing around that. Then I've looked at, you told us to look at 2 staircases. I've actually looked at 3. I've added the Foster and Partners staircase for Apple in New York as well, because I think it's quite relevant. So I've done the Alto, the Mies, and I've added the Foster on as well. So I've just condensed that case study onto that page there and looked at lessons learnt here on the right hand side. So this is the lessons I'm going to take forward into my own staircase, if you like. The same format here for the Mies staircase, and the same format for the Foster and Partners staircase. Then I go into design development. Excuse me, I've pulled together the sketches, so I'm just illustrating really where I started with these very rough sketches and rough ideas, how that developed forward. And then I wanted to introduce more of this graphic in. So this is one of the early drawings, just showing the graphic on the staircase, and ideas on how the staircase would be assembled. And then I've put a white model in just to show the outline of the staircase within the room. That was the point I was more or less going to finish, to be honest with you, but when I went back and looked at the research on the Mies and the Alto staircase, and even the Foster staircase, something kept nagging me, and I kept coming back to it for some reason. And it occurred to me that what they were all doing, the one real common feature was they were all stiffening the staircase up. Alto here was stiffening up with the steel beams behind the steps. Mies was forming this sort of brace through with these solid steel structures, and Foster was using this cantilever technique. And it just began to occur to me, is stiffening a stair a good thing? It sounds sensible, but when you look at the biomechanics of it, you've got an awful lot of potential energy as you walk down the stairs. Because you're on a stiff staircase, it's got nowhere to go, so it comes back up through the leg, through the muscle, through the joint. And it seems very sort of counterproductive. So if you look at a gym floor, for instance, it's sprung. So I just came up with the idea of, could we introduce some kind of spring into these steps? Not enough to make it sort of feel wobbly, but enough to sort of take the impact, if you like, and soften it. So I developed that idea a bit further. Sketching ideas here, I thought, well, if we can take something that absorbs that kind of energy, why can't we use that energy? If you look at this is a very basic spinning top. If you put that underneath a tread, so that as the tread came down, we got that rotary motion, we could turn potential energy into kinetic energy. So, why not? Did a bit more research. I found this company called PaveGen. PaveGen are already doing it. They've got these micro generators here fitting underneath the pavement. So as people walk along the pavement, they actually generate electricity. I thought it was a great idea. It's already on the market, so this is something I could do. So going forward, I'll quickly run you through the drawings that I'm at so far. I've done one drawing here condensing all the relevant building regs information into here. The stairs, the rise, the go, and the various regulations. Done the main plan. Elevation, I've still got to add notes to these. A lateral section through. More elevations. Notice I've solved the riser problem by putting a glass riser in here, so that we can conform to regs with this staircase. The whole thing's had to virtually be redrawn. It's amazing, all these little alterations. It was just easier to redraw the damn thing. Done quite a few details there, so I'm starting to see how we could use sandblasted glass onto here and how we could raise the treads at this point, how the handrail would work. That's looking at the idea of converting potential energy to kinetic energy. So if we spring-loaded this part of the step here, and we could have that generator underneath. That's the glass riser in the back, which is there as backlit. So I've done quite a lot of detail here on how we could actually do it. So that needs developing a bit more. I worked at the model. I've sent that away for 3D printing now. So that was the 3D printing model I've sent the guy. More details on this slide mechanism that I designed, because I want all these stairs, instead of being fixed, I want them to adjust into position so that it's very much a modular system. I've looked at all of the loads, impacting the load on the track, the load on the outer edge, how that would cause flexion, how we need to redirect that load back through the brace underneath. I'll probably take the lift out. I presume you don't want that. And then very quickly, just in the last minute, I've started to do a white model. This staircase has been completely redrawn now from the original drawing. So this now matches the drawings, the technical drawings exactly. So white model, white model, white model, and so on. I started to look at colour drawings. Not totally thrilled with these. They need a bit of work, but the basics are there. You can start to see all of these reflective materials working now. I have to play this back in slow motion. And finally, just in the last minute, I got the first model back from the printers, so I'm quite excited about this. So we can print this in 3D. Not happy with some of the details, so we're just in the process of cleaning the digital model up now, ready for printing next week. So hopefully I'll have these in a couple of weeks. I can start building the foam board model around it. So, sorry, ran over to 6 minutes. Thanks very much, and I'll catch up to you soon. Okay, bye.